Hey everyone, I'm Luke. Hello. So this is automatic Redis clustering and pitfalls. This is about open source Redis cluster, which we've used quite a bit at Twitch. And I want to basically tell you guys what I've run into and how I've tried to build around it. And the slide transition isn't working. There we go. So Twitch. I work for Twitch. I honestly was a little too lazy to Google like stats, but Twitch is big. We do video game live streaming. We're owned by Amazon. We're in Montgomery Station actually. We're just down in SF, really close, cool nearby, and we have a lot of backend infrastructure that uses Redis, and in particular one of my services. So you don't need cool stats. It's enough. Before I start, so at Twitch, I run a service that runs in bare metal. We decided to run Redis on-premise to minimize latency. But in hindsight, we probably would just use a managed solution in the future, especially based on this talk. You'll see the and pitfalls part of the talk, because somebody else can do this for you. You don't actually necessarily need to implement all this yourself, but this talk will give you at least some information how you could do it, how you could use open source Redis for clustering mode. And if you just want to use a managed solution and just be fine with that, then you can just zone out, like sleep, whatever. It's going to be an easy talk for you then. So operational goals. So we have a lot of different hosts at Twitch. We run our own data centers, at least and this service runs on those hosts. So we want to make it so operations life is easy. So we want to run, yeah, exactly. We want to run Redis nodes on hosts and just kind of run whatever, like just provision a host, just start up some Redis nodes that automatically create a cluster. We don't necessarily want operations guys coming in and typing commands to try and create the cluster themselves. We also want to just automatically create the cluster, so you can pretty much just think of operations as just hitting the on switch on a host, and all of a sudden the host will join an existing cluster or create one if it doesn't exist. Of course, redundancy. So if a host fails, we don't want to take down the website, which has happened. I mean, it happens to every big company that, oops, we forgot to have like a replica of the database. And that went down, and it's like, oh no. To that extent as well, we want to avoid local replicas. I say this because at least Redis cluster, that's not necessarily built in, where you can have a case where you can have a master node, and you can have a replica on the same host. So if that host has a bad RAM or something, you lose the replica as well as the actual master. So not a good thing. Scalability. So one of the really cool things with a Redis cluster and what really drew me to it is the fact that you can run these single-threaded nodes. Redis is just single process. It can't use more than a core. And it's really optimized to do that very, very well. The idea is that you can just run multiple processes, and you can run any number you want on the actual host to use as many cores as you potentially want to use. So that's one of the best things I would say about Redis is the fact that you can just run as many nodes as you want, and they add, and then eventually you get a full cluster. This is great for us because we can just, if we add a host, we'll just add the same number of nodes to the cluster, and it scales that way. So load balancing, we're almost done with the goals, but we want to make sure that, again, every host has the same number of nodes running on it. So if we have 3 nodes running on a host, we want 3 on every other host. We don't want to necessarily have one poor host doing too much work. So that goes the same with the slots, which is keys, effectively, and masters, because master nodes do more work than replicas. So effectively, we're assuming that we have this big data center that has hosts of all the same type, and we want to make it so we can basically turn on a host. It takes the same amount of traffic as every other node. It just automatically, big O-N scales up and onwards as you add hosts to the cluster. So operations loves me in theory if I do this correctly. In practice, they don't love me. So yes, let's write a cluster management tool. I want to go over what exists out there and why we decided to write our own, and how you would go about doing it, and et cetera. So first off, what's built into Redis? So Redis does not have an automated management for clustering. So Redis has a tool, Redis CLI, that lets you set up a cluster. It's a pretty cool tool. It has other commands like fix, rebalance, but it's very manual. The idea is you're supposed to have somebody wake up in the middle of the night and realize, oh, I have to run this super secret command to fix the website. If they don't, oops, the website goes down. You also have to create it. So let's say I provision a new host. I have to go through and I have to run this command to create a cluster or to like add to a cluster. So the Redis existing tooling for the open source clustering is very much manual. So you have to list the some flags. You have to list the IP port of every node you actually want to add to the cluster. Once it's set up, it runs pretty well, unless you like to make changes. So Redis cluster as a whole there's not too many tools out there. There are some open source tools. This is just what I want to point out, the built-in. Also, yeah, you shouldn't use loopback. And this is it from the example from the clusters tutorial. If you use loopback, and you don't specify the right bind address, they'll all advertise loopback, and then your cluster won't be accessible from outside of that single host. So yeah, some gotchas here is that to actually run the Redis CLI commands, a lot of the times you have to figure out what you need. Some commands take IDs of nodes, some take host port. Some of them, certain configurations, you need the special commands. So it's hard to automate this. Like you couldn't actually necessarily run just like, let's say, some script that will figure out which Redis CLI command to run. It's very difficult to figure out what to do. It takes a lot of, I would say, operational knowledge of Redis, which is not something, again, to be friendly to the operations guys. We have a lot of operations guys at Twitch, and almost none of them know how to use Redis. I don't want to have to teach them, how Redis cluster works, what commands to run. I want to write something, so they don't have to. Also, they have to wake up at 4 a.m. if they get paged, or sometimes I have to get woken up if they can't do it. And if you're running this big command, like this is a pretty sane command comparatively, but let's say you typo something, you just took down the website. It's not safe. So instead of alerting somebody, instead of getting a human in the process, we want to fix it. I'm a software engineer. I write software. I automate things. I try and get people out of jobs, so you don't have to. You don't need to pay somebody to wake up just and know about Redis. So there's a few different approaches. So without exploring really the open source space, let's just try to break them down into categories. So if I wanted to have some management tool, I could just have a single script that just sits there and pulls the state of the Redis cluster, and if it's in a bad state, it will fix it. This is kind of similar. There's actually a fix command in the Redis CLI, which will fix clusters and do stuff. You can also have multiple masters. You could have multiple nodes that all try to, for some redundancy, if that fix script goes down, what happens? Your Redis cluster will keep running just fine, but eventually it would get into a bad state, so you want some redundancy. And with redundancy comes coordination and synchronization. So you need some external source to make sure that the management tools aren't going to fight with each other. Or you can be really clever, like I tried to do, and just have decentralized management. Just have it so you have this script that just tries to fix it and fights with everybody and tries to use algorithms, and yeah, I failed. It's a really cool idea, because the idea is I want to be like Redis cluster. There's no owner of a Redis cluster. Every node kind of ends up gossiping with each other, and in theory, the management tool could work like that too. But there's some gotchas, hence the talk. So I want to go over more of the details of how Redis clustering works. I know that some of you guys don't know what Redis cluster is. And I know I'm glossing over a lot of important details, but I want to cover a little bit. So first off, you have these nodes, these Redis nodes. A lot of these talks, you assume everything is just a single Redis process. So when you issue a command, you send it just to that IP port. The way that Redis cluster works is you effectively have a bunch of nodes that end up joining together, and they all own a bit of the key space. So you can make them join each other with this meet command, IP port. So the idea is if you know one node in the cluster, you can say, hey, you meet this other node, and then they'll start gossiping amongst themselves, and you'll create a cohesive, like Redis application you can think of that can then use all your favorite Redis commands, with some exceptions. There's a few commands that don't work because the data has to be sharded. Maybe that's so for anybody, this is database sharding, is what Redis cluster is effectively. So if I'm creating a new cluster, I need to be able to run cluster meet on all the nodes. I want to make it so I can spin up my new host, call cluster meet on the existing nodes, and then I've joined it. So here's a little example where I have the new node on the left. I can call meet and give an IP address, and then it's effectively a ping command, and you'll get back gossip about every other node in the system. So the gossip is, without going into too much detail, it's pretty cool. Just every X seconds, nodes will send a random subset of other nodes they know about. And that way by meeting one, you eventually figure out everybody else in the cluster. Eventually consistent is the word for it. So yeah, that's all you have to do to create a cluster, right? Some gotchas there. So Redis doesn't have any discovery mechanism, which means that you need to figure out, have some sort of discovery mechanism. You need to, how do you detect that there's a cluster running, for example, in this data center? How do you detect what node is running in the cluster so you can join it? So you need some sort of third-party orchestration. There's no easy way. You could use, we'll go over the solutions, but fully joining the cluster also takes time. The idea being if you write a management script and you say meet, you can't assume that that node knows about every other node, at least for a couple seconds, which means whatever management tool you have to do has to realize that there is a gossip protocol there. So nodes will have incomplete views of the entire cluster while they're joining. That's a gotcha as well, so you need to make sure, either like sleeps or something, you need to make sure that you realize that there's this gossip going on. And then the random gossip to that point is, it's not fully random, but again, nodes will have different views of the world. This comes up a lot. So different solutions, like maybe you could just hard code IP port. This is great for a startup or something, or just like a side project. Like, yeah, just sure, this is my one master node. Just connect to that. That's the cluster owner. You could also have somebody in operations run a command. You can have them figure out what the single hard-coded IP port is, and then run the Redis CLI command. Maybe a LAN broadcast could do that, or external source is probably a little bit saner, like Zookeeper, Console, et cetera. There's a lot of different services out there, but you still need to have discovery be separate from Redis clustering. Redis is great for discovery once you've joined, because you can see which every other node in the cluster is. But before joining, you have no idea where they are. There's no discovery in that regard. Cluster leave. So you can leave, a node can leave a cluster. This is very dangerous, but what you can do is you can take the ID of a node and tell every other node to forget it. So what it does is basically any internal state it has about that node, it just completely removes it. And has a blacklist to make sure that that node doesn't try to join the cluster again. Because otherwise the node would be gossiped around, right, and it would rejoin naturally. So, hey, you can just, let's say you wanted to, and again, you're in operations, you want to deprovision a node, you would have to run cluster forget on everybody, on every node to try and tell them that, no, you shouldn't talk to this one anymore, I'm about to shut it off. Gotchas there. So make sure you don't forget the node before transferring all the data away, because Redis does let you do this. You can forget nodes that actually have data on them, or forget master nodes that have data. Every other node will be like, sure, yeah, okay, I no longer know about this one. I've just completely forgotten about him. And if you're in the process also of a failover, let's say you forget a replica while it's in the process of becoming a master, you just forgetting is also from each node's point of view. So one node can forget about another node, but not the other way around. So a lot of gotcha there. Replicas can't forget masters. So let's say you end up going through and try and make every node forget like this one particular one. You could totally get in the case where, oops, like this node will reject the forget command, and you'll get in this inconsistent state. The inconsistent state is also particularly problematic, mostly because Redis cluster requires consensus. So in order to mark a node as failing, you need to have a majority consider the node as failed, which is really, really cool. It's great for automatic failover to the point where you can just have a bunch of nodes. They all independently have their own health checks, and if a majority gossip that a node has failed, it counts as failed. The problem with these forgets is if you're the one that knows about a node, you can't get consensus that node has failed. We've had cases where we have nodes where they, for whatever reason, didn't get the forget command, either because they couldn't forget their master or whatever. And then they just have this entry in their nodes table that there's this node that's probably dead, but nobody else seems to think that it exists. And it's not gossiped because it's potentially dead. So yeah, forgets cause problems. And this is my little example here, where you can have issue a forget command to the 3 nodes. And one of the nodes can say, actually, no, I'm not going to forget that. And then it will have this entry at the very bottom saying, pfail means potentially fail in Redis terminology. I think this node is probably failed because my health checks aren't working against it, but nobody else knows about it. So I'm just going to keep it in that perpetual, probably failed, but I can never fully upgrade it. So this has caused a few issues, at least for me. Some solutions. This is maybe too in-depth, but yeah, you want to make sure at least that you first make sure that the node doesn't have, if you want to shut down a node, you need to make sure it doesn't have any data, either manually do a failover or migrate all of its slots. Then you have to do this like cluster forget on every node, and you just have to be very careful about making sure every node actually receives it. If you ever have this case where, again, you're running a command that does a mass forget, and it cancels or times out in the middle, you're in this really scary state where your cluster is going to be not going to reach consensus. Or do nothing. This is actually what I ended up doing for the longest time, where it turns out if a node's not alive, it's gonna be annoying because it's gonna show up as one of the members of the cluster, but it's gonna be dead, and for all effective purposes, it basically isn't there. It's just gonna be this like garbage that you of X members in the cluster. Yeah, you can totally, leaving a cluster is actually surprisingly difficult. I would say it's a lot harder than actually joining a cluster, which is interesting. Uncovered slot assignment. So here now we start to get into how Redis cluster actually works a little bit. I've tried not to have a big slide trying to document. I'm sorry if I'm confusing you all. The way that Redis cluster actually works is you have these slots. You have slots 0 through 16K. The idea is that you then hash a key, and it will go to one of these slots. Now, this is true for open source Redis. This is true for some of the other managed offerings, too. They just use open source Redis. They just do this under the hood for you. But the idea is that a node owns only a partial range of the slots, and you want to make sure that those slots are covered so that somebody owns the slot. And then clients will figure out who actually owns the slot. So here's a little example. First off is if I want to just run the command getX. Redis has a hashing algorithm that's advertised. It's both on the client and the server side. So the client knows that X when hashed equals 3999, and knows that based on the advertised slot ownership that the first node actually owns 0 through 5,461. So that means it actually should own X. And it immediately goes to the actual node that should own X. So this is great, because instead of having redirects or proxies, the clients go straight to the actual source of the data. There's some problems here, though. So first off, let me go back to the slide. So the command you actually run to assign slots at initial creation is the add slots command. You tell a node, hey, you're in charge of these slots. And interestingly enough, this is also one of the reasons why it's not easy to automate this, is you have to enumerate every slot manually. So 0, 1, 2, 3, 4, 5, up to 16,000. So you're going to want like some bash hackery if you want to do that by hand. But usually you want a tool to do this. Running these raw Redis commands is not not necessarily the easiest. And there's also an epoch, but basically the slot ownership is gossiped among every other node. So if one node says I own slot 0, it will tell every other node I own slot 0, and here's my epoch, which is used for tiebreakers. Epoch's kind of like the timestamp, more or less, when it decided it owned 0. But in the gossip space. Cool. So in this case, I've already have a setup cluster. I just called add slots on all these nodes to assign them. Add slots. So if you're thinking about, let's say I'm writing my cluster generation tool. I want to create a new cluster. How do I decide who's going to own the slots initially? If you have a managed, like if you have somebody in charge, you can say, oh yeah, this node owns these, add slots, add slots. Just be careful if you have multiple nodes that decide to own everything. So if you want to go to be the really smart, decentralized solution, you end up having nodes trying to own the entire key space. Because what happens is if a node doesn't own any slots, or if a slot is not owned, it will just error. So you want to make sure that at least one node owns it. But if you have all of them try to own the entire cluster, you'll just cause tiebreakers. You cause them to fight, and in theory, you can cause data loss as well. In the case of slot 0, if there's already data on slot 0, and somebody else says, hey, I own slot 0, it could just take over and clobber any data that was there. First off, I'm creating my cluster. One solution you can do is just pick a single node and tell it to own the entire key space. The idea is that you'll migrate away. The other option is to do it on every node. So you decide to shard up front, and you don't use a rebalance. So this is pretty easy, though. Not many gotchas here. This is actually kind of nice just for initial assignment. Covered slot assignment or reassignment. So to the example, let's say we had the cluster before, but the node on the right dies, and it didn't have any replicas. You effectively have this key space, these slots that are no longer covered. So you're in this situation where, oh no, like I forgot to, I don't know who covers slot 6000. And this is really bad because if you're actually running in production in this mode, you'll have a third of your requests effectively just error on the spot because nobody actually owns this data. And Redis doesn't have a built-in way of recovering either. Usually the way that the Redis cluster works is that you have replicas, and if a master dies, the replica will take over. But if there's no replicas, like let's say they died as well, or you just decided to be very bold and adventurous and just not use redundancy, you're going to have this case where your queries are going to keep failing until somebody steps in. Now this is the case where we wanted to avoid, especially. We don't want we want a system that self-heals. Redis does a really good job of self-healing, unless you're in this case where you actually have a master that doesn't have any replicas. The cluster won't recover until the master's turned back on. That's how you're supposed to fix it. You just turn the node back on, it will realize, oh hey, I still own this data, and it will, if it was persistent to disk, everything's fine. But if you can't turn the node back on, you're in a tricky situation. So a lot of gotchas here. So add slots, which your great command will actually not work if there's a master that it knows about. So if we're back to this world, that we know that the node on the right owned those slots, but it's failed. It's failed the health checks. My add slots command won't work anymore. It only works if nobody claims to own it, which is kind of annoying. But I also can't do a manual takeover because I need actually a replica in order to do a manual takeover. I can't create a replica either because the node has failed. So you're like, crap, okay, so there's slots that are uncovered, and I can't tell another node to cover them. So you also don't necessarily know, for example, if there are replicas, because it's perfectly valid for actually there'd be the master node that failed and replicas that haven't taken over yet, because it's an election, it takes time. It's kind of cool how there is a replica election. But you don't know what the status of that is. You don't know if that replica election is going to take place, if it's still going, how long to wait, because they do need a majority, a consensus of nodes before they'll do the takeover. And unfortunately, this is maybe a bug. This talk is kind of a bug report. I'm sorry, everybody, but the nodes, replicas will report their previous master ID. So let's say you have a replica that's replicating node A, and then we decide to switch it over to node B, but it can't do that for whatever reason, like maybe B turned off in the process, or there was some some failure where it can't actually sync the data, it can't become a replica properly, it will still report itself as replicating node A. So there may be situations where it looks like a master node has replicas, but in reality, those replicas don't know, like, they're actually in the process of connecting to a different node instead. And that loops forever. There's no timeout. So you could be in this case where, yeah, I'm still just reporting the old node. So you don't know when the cluster failover is going to take place. And by the way, I want to re-emphasize, this does not happen with managed Redis. A lot of people do this for you. This whole talk is like if you want to do it yourself. So, because you're like, these are a lot of gotchas, and this is something that I went into Redis cluster not knowing a lot of these, and ended up figuring them out through a lot of production incidents. So there's some solutions here. You need a timeout. You need to make sure that replicas eventually take over. You also need to, let's say you have this node, the dead node that owns like slot 6,000. The only way to run add slots and to fix the issue is to forget that node. You have to tell every other node to forget it and then quickly do add slots to say, hey, take over 6,000 and do the tiebreaker. So which is very dangerous because again, the issues with forget I mentioned before. And the hope is that the epoch will save the day. So if you have one node that knows about the failed node and thinks it owns 6,000, and then another node that claims it owns 6,000, but doesn't know about the previous one, you're hoping that the epoch collision will save the day and swoop in, and it will now cover the cluster, although you will lose all data. Like, there's no way to avoid losing data. And there's no way to bump the epoch either. So you get this kind of convoluted case to try and fix what really should be more of an edge case. But it's trying to say, maybe one takeaway from this is always have replicas, because if you don't have replicas, you'll get in a state where somebody's going to wake up and have to figure out how to fix this situation, and the answer is very difficult. Rebalancing. My key space, 0 through 16,000. Let's say I had 3 nodes in the cluster, and I want to add a 4th node. So it used to have every node owns a third of the key space. Now I want them to own a 4th of the key space, right? You actually have to do that manually. You have to do the migration and importing yourself. Again, a tool like Redis CLI will automate some of this for you. They have a rebalance command. But there's some issues there. So the way that it works is every slot is in a state of either stable, importing, or migrating. And you slowly go through every slot and you tell them to migrate to this one or import from this one, and then move the data over gradually. You choose the rate at which you can move data, which is really, really nice. You choose the rate of the rebalance, so you can do it either really quickly or really slowly. But you have to know more about what your actual use case is to decide what you should do. And yeah, you just keep migrating data until there's none left. So during the importing and migration as well, maybe there's a little example here. If I want to move from 2 nodes to, from one node to another, you would say that the slot is migrating and it's importing on the other end. And you individually migrate key and key and key. The way clients work, this is just a little Redis cluster thing, is they will figure out which node, so let's say this X hashes to 399. They'll first ask the owner if the data exists, if it was an existing key. And if it was an existing key, it can just be served from the original node. Otherwise, if it's a new key, it should go to the new node, the one that we're migrating to. So there's actually a redirect with Redis cluster during the importing and migrating state for clients. So you don't want to stay in the state too long, because it will effectively double your latency. So you need to make sure that whatever, again, automation does it relatively quickly without overloading the nodes. So going back to this slide again, oh, sorry. So these are actual commands. Again, you could run this by hand if you'd like. You can just connect to a Redis instance and run all these commands. It'll take a while. So you do need automation. You want to set the first slot as importing. You want to get every keys in slots. Cluster get keys in slots will just return an array of keys that exist. And you want to individually migrate from host, 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 and then say you're done. I'm not going to go into detail with these, but this is effectively what it looks like again. Some gotchas. So hotkeys. So the way that the data is sharded, we shard based on slots. So you have slot 0 through 16,000. But that makes the assumption, like let's say we evenly, like each node owns a fourth of the key space. That means that you want to make sure that your data actually hashes pretty well. If your data doesn't hash evenly across the key space, like let's say you have a hotkey. For example, maybe there's just in our case, some stream that's really popular. Then you have a case where a node will have more work than others. A slot will have more work. So if your data shards nicely, it's kind of easy to write automation. You just kind of say like you own a fourth of the cluster. But if it doesn't, like let's say you have the hotkey problem, you then have to write tools that try to resize based on workload, which gets a lot more difficult. You're no longer doing this very naive like cluster create command like you do from Redis trib, not trib, the Redis CLI. You now have to actually have some sort of automation that goes through and looks at the CPU usage of nodes and figures out, should I take slots away or given, you constantly keep rebalancing the cluster. And error handling. So I noticed all these commands. What happens if the node goes down or is overloaded while you're running these commands? We've had cases where we start migrating slots away when we want to shut off a node, and somebody shuts it off too early. And now we're in this state where we were still migrating a slot, but the other side no longer exists, so the source no longer exists. And the cluster's in this weird kind of bookkeeping state where it thinks it's still doing a migration. So you need to have some sort of rollback mechanism or some sort of recovery mechanism, and a lot of gotchas there. Importing and migrating is not gossiped, so this is less of an issue, but if you're really writing your own thing, this just means that only the node that's doing the migration or importing actually knows about it. So if you're, it's not going to gossip to every other node saying there's a migration going on. It's just A to B, A and B know about the migration. The other nodes have no idea what's going on. So again, if there's a failure, like let's say B goes down, node C doesn't realize there's a migration happening and doesn't know how to step in, especially if C is a replica that took over. Yeah, migration's not being gossiped is mostly an issue if you just happen to have a failure while you're in the middle of a migration. And one more gotcha. I'm going to say that word a lot. So epoch collisions. What can happen is this epoch is more or less a timestamp that says that is used for collisions. So when you migrate, when you import a slot, you will bump your epoch to say, I now own this slot, and I own it at this timestamp. So, and this timestamp is +1 of the highest known epoch every other node has in the cluster. So the thought is that if a node goes down, comes back up, it'll have an epoch from much old, like an older epoch. So the other nodes in the gossip will say, actually ignore that guy, he's out of date. This person, this node is the one that we should trust because he's a higher epoch. The main problem with this is that if you actually, since it's bumped when you're importing, if you try to import and migrate at the same time, you'll cause issues. What can happen is there's a race condition where because ownership is gossiped, and because you bump epoch after importing, you can actually cause nodes to think that you own the wrong key space. I don't have an example here. I can make one, but effectively you can create a situation where your Redis cluster will be stuck thinking that it thinks a node owns the slot, but it doesn't actually. And the gossip will not recover it. So you need to be very careful, make sure that you don't import and migrate at the same time. This is especially bad for like a hotkey or hot slot problem, because let's say I had this node that was super overloaded, I start migrating away from it, and then the one it's migrating to is overloaded. I can't then have that one offload. You have to wait till the migration, like, you can't import and migrate at the same time. So it causes issues. Inconsistent view of the cluster is a particularly bad state because you end up getting this if the nodes don't agree who owns what, clients will just break randomly. It's never a good sign. So assume all slot solutions, you can assume all slots are equal, or do your own hotkey detection. Good luck. Don't import migrate on the same node, so that means you have to wait for gossip to propagate. That means you have to check every node to see if it's gossiped. And then try to figure out if migrations failed, which is also very difficult. How to fix that is another slide in itself, but again, I don't want to bore you guys too much more. Replica rebalancing. Almost there. We almost have a fully functional Redis cluster automation. The idea is that you have replicas that will have a one-to-one copy of a master node. You tell them which ID to replicate, and then they'll just get a stream of data. They'll get a stream of pretty much every command, such that they can then become the master if there's a failure. Redis does have a way of automatically moving replicas. There's this migration barrier to say that, let's say, if it's value 2, if a node has 3 replicas and another one has 1, it'll move one of those replicas to the other node. So it will try and rebalance. So this is an example where we have the 2 master nodes and 4 replicas. Initially, we have 3 replicas for the first one, but the migration will decide, actually, let's take one of these replicas and move them to the new master. So instead of having n+3 redundancy and n+1, you have n+2 in both cases, so they can handle the same number of failures. Interesting gotcha here. It's in this slide, actually. Replica migration doesn't care about the actual IP or the host of the nodes. So in this case, I actually have 2 localhost replicas for a localhost master, and I have 2 1111 replicas for that same IP address as well. So if there was a failure, let's say the host went down, I would just lose the master and the replicas as well. Yes, because replicas and masters can be on the same host with Redis cluster. The CLI command will try to avoid doing that for you on creation, but the automatic rebalancing won't. So you don't want a host failure to cause data loss. You don't want to be this, it would cause the uncovered slot problem that I mentioned, where nobody seems to know who owns what slots. Yeah, it's kind of a pain. And I guess replicas also can get stuck failing to replicate. This is less of an issue, but you have to actually look at the log files to figure out when a replica's stuck, which I've had to do at times. So solutions, we disabled the built-in logic, just set to value 999 or 99, so it will never happen, and try to make it so hosts replicate other hosts with different IP addresses is the simple solution. But in theory, if you want to get really complicated, you'd start looking at the switches, you start looking at the availability zones or whatever. You start to try to figure out, like, how can you decouple failures as much as you can. Role rebalancing. So during a failover, you'll have a replica will take over for a master. And the old master, when it gets turned back on, will become a replica. It will basically wake up, realize, like, oh, hey, I'm part of this cluster, right? Oh, yeah, I own these slots with this epoch. And then it'll be told that, no, somebody else owns it now. And it'll be like, oh, OK. And it becomes a replica. Unless the node's never turned back on. We do have cases like, for example, you're deprovisioning, or there's just some catastrophic hardware failure. You can't turn it back on. So you kind of have this flow where a replica becomes a master, and master could become a replica. So here's a little example. If I turned off the node on the left, one of the replicas takes over as the new master. We had this state where now we have 2 masters and 3 replicas, whereas before we had 2 masters and 4 replicas. So what this means is that every node failure actually means -1 replicas. Because if a master fails, a replica becomes a master. So that's always -1 replica and 0 net change in masters. And if a replica fails, you just lose a replica. So that's just net -1 replicas. So this is a problem when you have a big cluster, because it means if you have, let's say, 30 hosts or 30 nodes, every time you lose a node, you lose a replica permanently. So you have to either spin up new replicas to replace them, or convert masters to replicas somehow. So you could create replicas. So you can be in this case where I just start spinning up new Redis nodes as needed. So instead of having a fixed like 3 nodes per host, you could have 3+ nodes per host and just create them as needed. The main problem here is that, again, the number of nodes in the cluster will never decrease because you always need replicas to replace any failed nodes. So you do have a case where we started with like three nodes per host, and in some data centers we found there were like 6 nodes per host eventually. So we had to switch away from this approach. And you could actively demote masters as well to replicas, which means you have to do the slot migration, you have to move away any data, you have to make sure that nobody tries to migrate data while you're doing it, and you can basically take an empty master and make it a replica. So it's not the most trivial thing, but you can actively demote masters, but it does require moving any data that was on the masters. So a little conclusion here. Hopefully I didn't gloss over things too much, but you should be scared. You shouldn't understand most of the things I talked about because Redis cluster management is just hard. The open source, I really love the theory behind Redis cluster. I think that it's the eventually consistent design is amazing. But there's probably too many gotchas. There's not enough tooling around it. And you should probably just use the managed solution. I've said this as well. Twitch works for Amazon. Not Twitch works for Amazon. Twitch is part of Amazon. So there's a little disclaimer there, but it's probably not worth the effort. It wasn't worth it, I think, for my project, because I spent a lot of time working on this. And hopefully a good management tool exists at some point. So I can do other things and not give talks like this. So if anybody's feeling inspired to tackle these problems, go for it. It'd be great. But there's a reason why managed solutions exist. And in this case, there's actually a lot of hard technical decisions and problems behind it. So that's my little conclusion. I'm Luke, Curley at Twitch if you want to email me. And any questions? Was the question?
Have you tried alternatives like Envoy proxy or just application-side sharding?
No, this tool for Twitch, we've been working on this for a tool for a while, before at least there was any existing ones. I didn't do necessarily too much research either. I've been trying to maintain this tool more than anything else in Switch. So no, I haven't tried alternatives.
Is there other questions?
Is your tool available?
No. We thought about it, potentially open sourcing it, but I'm actually just not happy with it. It's something where I think there's a lot of cool ideas there, a lot of cool approaches, but it doesn't do enough to justify open sourcing it.
Others? No?
Any questions? No?
All right, Luke.
Well, yeah.
Thank you very much.
Thank you so much, everybody. Pleasure.